Hey, welcome back to session 21 on plane strain. This is our second part, and in this part we're going to discuss the use of Mohr's circle to be able to calculate these transformations that we've been discussing in the previous part with those transformation equations. So we're going to be essentially doing a very quick overview of how we can use Mohr's circle with plane strain. Is very similar to Mohr's circle for plane stress. So we have the idea that we're going to figure out where the center of the circle is based on the average of the normal stresses. We're going to figure out where the point of location is based on sigma x, comma, tau xy. We're going to figure out what the radius is between the center, or using the hypotenuse between the center point of the circle and the point that we're interested in. And then we can look at what happens as we apply rotation to the element. And that corresponds to 2 theta rotation on Mohr's circle. Now, the equations for Mohr's circle for plane strain are very similar. Okay, so these are the ones for plane strain. Okay, but remember in our last session we discussed how we had a substitution of the gamma x prime y prime and the gamma x y for tau xy and or tau x prime y prime and tau xy. And with that substitution, there's a factor of 2 that comes out in the derivations that you can take a look at either in Hippler's book or online. So one thing we need to keep track of when we do Mohr's circle is the factor of 1/2 that influences the depiction of shear strain. And that plays out in the axes. So we have a normal strain axis, or an axis for normal strain, epsilon, just like we had for sigma. We have the y-axis, again, being positive downward with our particular decided conventions. And now instead of putting tau down here, we put gamma xy over 2. When we find the middle of the Mohr circle, we use the average of the normal stress or normal strains, just like we use the average of the normal stresses here, and we can pinpoint that center. We can write out or put out the point corresponding to epsilon x and not tau xy, but gamma xy over 2, okay, like that, okay, gamma xy over 2, and that gives us that point, and then we can go ahead and draw a circle, okay. We probably want to know what that radius is, so to do that, we should figure out what the adjacent side of the triangle would be, and we can figure out what the opposite side of this triangle is. When I say I'm going using an angle here, that is just the gamma xy over 2. Okay? So that radius comes out and plays a role here. So there's not really much more to say at this point, but to do some examples and problems. And so I'm going to actually just throw it right at you to go ahead and work on one question where we have an element with plane strain as specified here. Okay, so use Mohr's circle to find the largest principal strain. And then another question where we're going to look at figuring out the absolute max shear strain, okay, using Mohr's circle. So that's the opportunity that you have, and that concludes this part. You're probably grateful. It's a little bit shorter this time, okay? I'll see you in the next portion.